Hi everyone. In this video, I'm going to talk to you about the terminology that we need to know and understand for our circles piece of this unit. And so we're going to be looking at all kinds of circle properties, but before we can use those properties, we need to understand what the terms actually mean. So what is a chord? What is a secant, a tangent, a diameter, a radius, an arc, all of those things. So in this video, I'm going to kind of give you some examples of that. But before you even go any further, you need to look at the vocabulary graphic organizer that's in your packet. It's on page 17 and 18. And in Google Classroom, there's actually a file where that's filled in. So you need to kind of go ahead and fill in page 17 and 18 in your packet so that you have something to reference back to. That's also something that you're going to end up turning in page 17, 18, and 19 when you actually submit your assignment. So make sure that you've done that and that you've gotten those notes first. And then in this video, I'm just going to kind of briefly go over those terms just to make sure, so I can actually say it and then give you some different examples as well. All right, so I'm going to share my screen. Okay, so this is what we should have. Hopefully you can see all of this. All right. So the first thing, I'm just looking at some of the terms. And so this is a circle. And I know that seems so stupid because obviously you know what a circle is. But a circle is, specifically all of those points, an infinite number of points that are the same distance away from the center that basically form this shape. Okay. So we're looking at a circle. You do need to know that they name a circle by whatever the point is in the center. So it might be point P, it might be point M. I mean, it could be anything. Okay, but that is the center, and that's how they name a circle. All right. You also need to know what a radius is. A radius is basically any segment that goes from the center of a circle to the outer edge of the circle, just the edge. That is considered a radius. All right. And it only goes halfway across. All right. So this is a radius. Now you also have a diameter. Now a diameter is sort of like a radius. It does go through the center. However, the diameter has to go not just through the center, but it has to go all the way across. So it goes from edge to edge in a circle. Okay, but more specifically, it goes through, of course, the center. All right, so that's a diameter. I don't know how well this is going to work with all these words and stuff, but I'm going to try. All right, so we also have something called a chord. Now, a chord, it goes from edge to edge in a circle, but it doesn't necessarily go through the center. So this right here goes from edge to edge. That's called a chord. Again, it can go through the center, okay, but it doesn't have to. So a diameter is a type of chord, but because the diameter goes through the center, its most specific name is diameter. So it is a chord, but it's also a diameter. All right. Diameter goes through the center though, but if it doesn't go through the center and it still goes edge to edge, that is a chord. We also have something called a secant. All right. Now, a secant, it can be something that goes through the circle, and it goes through the circle in exactly two places. That's a secant. All right. Now, a secant, it can touch your circle at two places, but notice that it goes beyond the circle. All right. That's a secant. It can be a line where it continues on and on forever. It can be a segment, but it does have to touch in two places. All right. So then another thing we have is something called a tangent. Now, a tangent, let me see if I can get a different color. only touches your circle in exactly one location. And it's harder to see here but it does touch that circle in exactly one spot. Okay, only one spot. So, in that little spot where it touches, right here, if I can, like right here, that one little spot where it touches, that one little point is called a point of tangency. All right, so this is called a tangent. Then we have a point of tangency. All right, so both of those terms are something that you need to know. All right, so this whole entire thing is called a tangent, and then this little one single point is a point of tangency. All right, and hopefully that's making sense. Now, the tangent can be a segment or it can be a line. It doesn't really matter. So it can either have a start and a stop, or it can continue going forever and ever. All right. So, some things that may help you remember things. All right. Because most of the time, the secant and the tangent are the two that people get mixed up, and the chord. Sorry about that. So, this is how I remember it. All right. So, if you think about a chord on, like, say, a guitar or something like that, it's connected in two places. So it has a definite start and a definite stop. All right, so that's a chord. And then a secant, I know this is cheesy, but how I always remember it is somebody once upon a time said, see, it can't stop on the circle. And so it has to extend beyond the circle in order to be a secant. See, it can't stop. Now, this secant, it technically could start and it could be like this. This is still a secant. Now, and here it doesn't keep going, right? Okay, but on this side it does. So the key is that it has to continue past the circle. Okay, it touches the circle in two places and it has to at least go beyond the circle in one direction. All right, so see, it can't stop on the circle. That's a secant. A chord, like chords on a guitar, it does stop. All right, and then a tangent. Well, I don't know. This is kind of cheesy too, but a tangent, a true gentleman will never cross the line, or in this case, they'll never go into the circle. I don't know. That makes no sense, but anyways, it only has one point on the circle. It will not cross those boundaries. Okay, a true gentleman will never cross the boundary. All right, so they'll never go in there. All right, so that's the basic terminology on page 17 and the very top of page 18. All right, now you also have some different types of arcs. All right, so we need to talk about those. So you have something called a minor arc, a major arc, and a semicircle. Now, a minor arc has to be less than 180 degrees, okay? Less than 180 degrees. So make this a little bigger. All right, so this right here is considered a minor arc because it's less than 180 degrees. All right, so minor arc, less than 180 degrees. All right, make it kind of matchy-matchy. All right, now if it is more than 180 degrees, so something like this, it goes maybe from here and it goes more than halfway. Like this would be halfway, right? So that's halfway. If it goes more than halfway, then that is considered a major arc. All right, so a minor arc is less than 180. A major arc is more than 180. All right, now a semicircle is exactly 180. All right, so let me see how I can do this. So if this is like half and half, right, then this right here would be a semicircle because it's exactly 180 degrees. It's half of my circle. Okay, so semicircle, exactly half, which makes it 180 degrees. Minor arc, less than half, so less than 180 degrees. Major arc, more than half, so more than 180 degrees. I do want to caution you, that major arcs are always going to be labeled with 3 letters. So for example, if I labeled this A, here was a B, pretend there's like an actual point there, C, D, because of that little starting point right there, right? Okay, so if there was an actual legit point there, I'm making some points so that there's actually points there. All right, then this minor arc would be named AD, okay? And it's always the shortest distance, A to D or DA. The major arc, you couldn't say AC. The reason why you can't say AC is because you always have to go the shortest way possible if it's 2 letters. And so AC would be this part right up here. Well, that's not a major arc. AC would be actually a minor arc. But if I labeled it ABC or CBA, then that gives me a roadmap and it's the longer route. So that would be considered a major arc. All right. And then, of course, a semicircle is only halfway. All right. And most of the time it's 3 letters, but sometimes it can be 2 letters. Now, you also have 2 other terms on there called a central angle and an inscribed angle. All right. Trying to get this. Okay. So a central angle goes from, it starts, well, that's fine. It goes from the center and it creates an angle. It can go beyond the circle, but the key is the vertex has to be on the center of the circle. Okay, so this is a central angle. All right, the key is the center is on the circle or on the center of the circle. Sorry. All right, that's a central angle. Now, an inscribed angle is going to be where it goes from the edge of the circle and it can go through the center like this would work right here, or it could go like this. I mean, it can go through the center. It doesn't really matter where it goes. I'm going to make it not, but it could. So I don't want you to think it can't go through the center, but the key is where is the vertex. All right, so this is called an inscribed angle. All right, and it's called inscribed because the vertex is on the circle. All right, so that's what makes that an inscribed angle. So it's all about where the vertex is. So here's the vertex, it's on the circle, on inscribed. Central angle, on the center, central angle. Okay, so that's our basic vocabulary. All right, so now we have some questions like this. So this is similar to what you'll see on page 19 in your packet. So it wants to know AB is called what? Now you'll notice that AB is in 2 places here. This is a segment, this is a line. The segment goes only from here to here and it stops, okay? So that would actually be a chord. Now, this one, because it goes and it's a line, which means it goes beyond the circle, is called a secant. All right. Now, EG, the line, is a tangent because it touches only at one point and it keeps going. So that is an example of a tangent. DB is a diameter. Now, technically, it's a chord as well, but the most specific name is diameter. BC only goes from the edge to the center, so that's a radius. And I skipped this one right here, FAD. FAD. It goes a long way. All right, so from F to A to D. All right, that is considered a what? Major arc. All right, so I'm going to make that go away so that you can still see all the letters, but it's a major arc because it's more than halfway. All right, so that's how we would name those things. All right, so if you look at this is similar to what you see at the bottom of your page. So when it says the M right here, that means the measure. All right, so the measure of ET. What you need to know is that the measure of the arc, it's going to be the same as whatever the central angle is. So central, same. So if this angle is 65, then that means this arc right here is also 65. So 65 degrees. All right. So this right here is 65. So this is 65 as well. All right. Then it wants to know the measure of SF. Now we don't know that angle, right? However, we do know that a circle is 100 or 360 degrees. So half of a circle is 180 degrees. And so if we subtract 90 and 65 from 180 degrees, well, how many degrees does that give us left, right? All right, so it would give us only 25 degrees left. So if that's 25 degrees, then SF is 25 degrees. All right, feel the need to make those a different color. All right. So now it wants to know what is the angle measure. See how these symbols are different, how this has an arc symbol above it? That means it's asking about the arcs. But this is talking about the measure of an angle, and it says EMS. So EMS is this entire angle right here. So that means that we need to know from E to M to S. That angle measure is 90 plus 65. So that would be 155 degrees. All right. All right. So then the next question is asking about an arc ETF. E to T to F. And you have to follow the roadmap. Well, that's half of a circle. So that would be 180 degrees. All right. Got all kinds of things going on over here. Okay, so then it wants to know the measure of EU. EU, remember it's two letters, so you always go the shortest distance. So that means I only want this section here. And since this part is 65, then how much is this part? Well, we subtract it from 180 and we get 115. So this would be 115 degrees. Now, this next part wants to know what kind of arc is it? Well, ES, if it's two letters, then you automatically know it has to be a minor arc. And that's because in order for it to be a major arc, you'd have to have three letters. Because remember, two letters, you always go the shortest distance. So ES is from here all the way to here. So that is considered a minor arc. Now, TF is also considered a minor arc because TF only goes from here to here. All right, so again, that's a minor arc. Now, these other three have three letters, so that's a pretty good clue that more than likely it's going to be a major arc. All right, so E or it could be a semicircle. So EFS, E to F to S. Now be careful, not ESF, right? If it was ESF, that would be a semicircle, but we have to follow the roadmap. So from E to F to S. So E to F to S. That is more than halfway, so that would be considered a major arc. All right. Now let's take a look at FUE. All right. So F to U to E is halfway, so that would be considered a semicircle. Right? And then the last one, TUF. So T to U to F. And I had to go in that order, and that's more than halfway, so that is considered a major arc. All right, so that's how you identify those. That's how you find the different measures, and hopefully this is making sense. All right, so that is some notes for pages 17 through 19. So now you'll complete your notes, complete the practice on page 19, and then you'll submit that to the assignment. All right, y'all have a fantastic day.